Welcome to Introduction to Composites course. Today is the third day of the first week of this course, and till so far we have been introducing and giving you some basic information about what are composites and what are their different applications. What I plan to do today is to give you an overview of what different types of composites are there in the world. So, what I will be essentially doing is classifying composites based on different types of constituents. Okay. So, what we will discuss today is classification of composites. And when we are doing this, we are only going to address engineered or engineering composites. We are not going to worry about naturally occurring composites such as wood or bone or granite and things like that. So, we will talk about, we are going to do this classification in context of man-made composites. So, we have engineered composites. Okay. And broadly speaking, you have two types of composites. So, the first category is particulate composites, and the second category is fibrous composites. Okay. So, what is particulate composite? Particulate composite is a composite material which has a mixture of particles, for instance cement, for instance concrete, which is a mixture of particles and cement. So, it has a mixture of particles or some lumpy things and a matrix material. In concrete, that would be cement and sand. And in fibrous composite, you have fibers, that is one constituent, and other constituent would be some matrix material. So, that is there. And another way to explain this is, what is particle? A particle is something which is not long. Okay. So, if you look at particle, this is not, this dimension is not very large. Its aspect ratio, or another way to look at it, is aspect ratio. You take its largest dimension and the smallest dimension, the ratio of those two is not very large, but if it is a fiber, it may be a short fiber or a long fiber. This dimension, the ratio of these two dimensions A and B is very large. Okay. So, particulate composite has a lot of particles bound together by some matrix, and fibrous composites have fibers, and in fibers, what is the definition of fiber? That it has a high length to diameter ratio. Okay. So, that is the basic thing. Now, so this is the first category of composites and this is the second category of composites, particulate and fibrous. Now, let us look at different types of particulate composites. So, a particulate composite can further be classified into two groups. So, the first group will be where particles are randomly oriented. Okay. For instance, in concrete, all the particles or the pebbles, they are not aligned in some particular direction. Okay. And then the other group would be directionally oriented. That is directionally oriented, or it has a Actually, I will not call it directionally oriented, rather it has a preferred orientation. So, that does not mean all the particles are in one particular direction, but broadly speaking there is some direction to the orientation of particles. So, I will say preferred orientation. Preferred orientation. Okay. So, this is A and this is B, this is A. So, 1A is randomly oriented particulate composite and 1B is preferred orientation composite, which is particulate in nature. Now, let us talk a little bit about particulate composites. So, what is so this is some randomly oriented composites, particulate composite. It has these blocky or lumpy particles, and then of course, as I said, there is this matrix material. Why do we use them? One reason we use them is if we want to increase the stiffness. Stiffness of material. For instance, if you take a slab of cement and put some compressive load on it, it will have some stiffness, but if you have a concrete, if you inject it, mix it with lot of these pebbles and particles, then it becomes significantly stiffer. So, it can take much higher compressive loads. Okay. So, a lot of times if we have to increase the stiffness of the material, we mix them with some particles. Okay. And these particles should be stiffer than the material, the matrix material, then only it will increase the stiffness. The weak thing about, or the not so good thing about particulate composites is that their fracture stiffness, fracture toughness is reduced. They tend to fracture easily. Why? Because the bonds between the particle and the matrix is not very good, and those are the places where you have a probability of getting cracks developed much earlier. So, if you take one of these composites and try to bend it like this, it will crack very easily along the points where the matrix touches the particle, okay, at that interface. So, that is one reason. There are several applications where they are also used to withstand high temperatures, And one example of that, we have already discussed this earlier, is called cement. Okay. It is called cement. Here you have particles of ceramics embedded in a matrix of metal, and these things have very high wear resistant and temperature resistance. Okay. So, to withstand high temperatures and to have high wear resistance. So, cements do both these things, they have temperature resistance and they also have wear resistance. So, this is some basic information about particulate composites. So, we are done with this. Next, let us look at fibrous composites. So, now fibrous composites, again they come in two varieties. One A and 2A and 2B. So, 2A would be single layer, okay, and 2B would be multiple layer. 2B would be multiple layer. Now these, so what does this mean? In single layer composites you have fibers, it is just one single layer, okay. So you can have a thin sheet and maybe the fibers are oriented like this, or there could be a case where fibers are oriented in both the directions, it all depends, but it is just one single layer. So this is a single layer fibrous composite, but then you can have another composite where there are several layers like these. Okay. And each layer may have a single layer of fibers, but then you can stick them together and that is a multiple layer fibrous composite. Okay. So this is multiple layer fibrous composite. This is one type of multiple layer fibrous composite. Now both these composites rely on fibers to increase the properties of the material. Now remember, I have not yet said whether these fibers are long or short, they could be either, but here we rely on the fiber to make the thing either stronger or stiffer or lighter and so on and so forth. So that is the purpose. So this is about fibrous composites. Now these single layer composites, I can again break them into two categories. Okay. I can again break them into two categories. One is longitudinal orientation. Longitudinal orientation. What does that mean? That the fiber is aligned along the length of the composite, and the other one is bidirectional. Actually, maybe a better word would be unidirectional and here it is bidirectional. Excuse me. Bidirectional. So this is A and this is B. So unidirectional composite which is fibrous and single layer, that is 2AA and this bidirectional is 2AB. Okay. So let us look at a picture. So if you have these are all fibers, but they are not long and continuous. They may be short or long, but here this is unidirectional fibrous composite. Okay. An example of a bidirectional single layer composite, it will be something like this. You have fibers in this direction and you may also have fibers in this direction. A very good example of a bidirectional single layer composite would be if you take a piece of this cloth. This cloth has fibers woven in both the directions, they are woven like this and like that, right, and you immerse it in some epoxy and you bind it, then you will get a bidirectional single layer fibrous composite. Okay. So this is bidirectional. And then you can further break these guys into short fibers and long fibers. Same thing here, you can break them into short and long. A lot of times we do not call them long fibers, or we can also call them continuous fibers. So, we can here also we can call them either long fibers or continuous fibers, and later we will actually define what is meant by long fiber or continuous fibers, what is the meaning of this in a mathematical sense. So, this is how single layer composites may be classified. Now, multiple layer composites, we can further categorize them as laminates, or why we can make them hybrid laminates, hybrid composites. Okay. Now, what is a laminate? So, a laminate is when you have several layers of single layer composites, but so maybe this is the first layer, this is the second layer, and you stick them like this. Maybe the third layer is like this, and the fourth layer may be oriented in some other direction. So, all when you stick them together, each layer by layer, the overall thing, which is a combination of several layers, is called a laminate. So, single is called a lamina, and if you stick a lot of lamina or layers together, then it is called a laminate. So, that is a laminate. And hybrid composites, things become even more complicated. So, here in a laminate, the fibers are only in the plane of the each layer. So, fibers may be running like this, or they may be running like this, or both. But in hybrids, the fibers may also be running in the thickness direction. So, these are more complicated structures. So, there may be hybrids like these. Okay. So, this is the overall classification of composite materials. Next, what we will do is we will start looking at some of the details of some of these things. So, one thing we have discussed in a lot of times, I mean we have addressed talked about, is that a lot of these engineered composites have fibers and a matrix material. Okay. Lot of these. So, fibrous composites are made up of mixtures of fibers and matrix materials, and the question is, why do we use fibers? Why do we use fibers? And the answer to that is, we use these fibers in a lot of cases either to make them stronger and or to make them stiffer. Now, these are two different words with two different meanings, and the third reason could be to make things lighter, for the same stiffness or strength. So, if I want a structure to be having the same strength, so that it can bear the same amount of load, let us say maybe the load carrying requirement is 20,000 newtons, I can make it from steel, it can be heavy. I can make maybe the same structure from composite, it will be much lighter, several times lighter, but it may still be able to bear the same load. So, these are in general the big reasons, either you have to make things stronger or stiffer or lighter without necessarily increasing the mass, even though you want the same stiffness or strength. Now, before I discuss further, sometimes we confuse between strength and stiffness. So, let us get this clear, what is strength and what is stiffness. So, strength, what is the strength of a structure? It is the maximum load which the structure can bear without breaking. So, for example, there could be a bridge, you are designing a bridge and you want to make sure that if you put 1000 tons of the load on the bridge, it should be able to survive it, and this load could be because a lot of trucks, cars, vehicles, people, and also the weight of the structure itself, and it should be able to bear all this mass or all this weight and should not still break. So, that is known as the strength of the structure. Okay? That is known as the strength of the structure. Stiffness is somewhat different. So, but before we go to stiffness, this strength is related, it is related to material's strength. So, what would be material's strength? Either it could be ultimate tensile strength for regular materials, isotropic materials such as steel or plastics, either it could be ultimate tensile strength, or it could be the yield point, or it could be the shear strength, or it could be the bending strength of the material, right. So, this strength of the structure is related to material strength. So, what are so it could be either ultimate tensile strength or yield point or bending strength and so on and so forth. Okay. Now, stiffness is the deflection in the structure per unit load. Okay. That is what is stiffness. So, what does that mean? Suppose this is a pen, if I keep on bending it, I apply some load here, at some load it will break. Okay. That will be called the strength of this pen, but that is not same as stiffness. Stiffness will be, suppose I apply 5 newtons here and 5 newtons here, and because of it there is a deflection of, let us say, 2 millimeters, then I will call it that the stiffness of this structure is 5 divided by 2, that is 2.5 newtons per millimeter, 2.5 newtons per millimeter, that is the stiffness of this structure. Okay. And the stiffness of the structure in general is very strongly related to what? Young's modulus. Now, this is in context of regular materials like steel and glass and plastics. In composites, there is something similar to Young's modulus, but we do not call it Young's modulus. Okay. So, but anyway, it is related to Young's modulus of the material. It also depends on geometry and shape of the structure, but it also strongly depends on the Young's modulus. So, lot of times we get confused between strength and stiffness. If we have to make things stronger, then we have to make sure that it has higher strength. If I have to make things stiffer, I have to make sure that its Young's modulus or modulus becomes larger. It could be Young's modulus or shear modulus or bulk modulus, one of these things. So, when we use composites, a lot of times fibrous composites, we either are trying to make things stronger or make things stiffer or make things lighter for the same stiffness or strength. These are the 3 things. So, if I am trying to make things stronger, then my focus will be to ensure that the material strength of the composite is high. If I am trying to make things stiffer, then I have to make sure that the modulus of the composite should be as high as possible. And if I have to make things lighter, then I have to make sure that the density of the material should be as low as possible without reducing its strength or modulus. Okay. So, this is the thing. So, the next question is, why do we use fibers? or rather why do fibers work? Because people have made a very large number of applications of fibrous composites, and there they do not use, suppose for instance in fibrous composites there could be glass fiber plus some matrix. So, you mix glass fiber and matrix and it helps you increase either the strength or the modulus, or you can make things lighter. But if you do not use glass fiber and rather instead of that you use regular chunky glass, you will not have success. So, the question is, why do fibers help us in making things lighter or stiffer or stronger things? So, this is an important question, and this is something I wanted to pose this to you. What I would recommend is you please go and explore it on the net or in the books which you have been using, and then tomorrow when we start the new lecture, we will come back to this question and we will try to understand why do fibers work, and regular materials in bulk phase they do not give us the same advantages. So, with this background I wanted to conclude our discussion for today, and I look forward to meeting you tomorrow. Until then, have a great day. Bye.